Okay, so we're going to run through how to produce the Crystal Bridges model the same model that we produced earlier in the term in just Rhino. We're going to reproduce using Grasshopper, and you can see all the layers here. Um, this is all a Grasshopper preview with just different colors applied. But we have our primary beams, secondary beams in blue, the tertiary beams in purple, and a skin that's been modeled in between those, all with a little bit of offsetting between each element to allow for some details to be included at some later phase, and also so that we don't have any intersections or collisions. Okay, so this is more or less what it looks like. We'll run through what the parameters are and how to affect those and how to make changes to this. And we're going to get started using just 3 base curves, which is what your base file has. So I'm going to minimize this, pull up the other file, and get started. So the first thing we're going to do is drag these. We're going to bring these curves into Grasshopper. So I'm going to go to Parameter and Curve and pop that onto the screen. And I'm going to right-click on that component and set multiple curves. And I'm going to select these in order. So I'm going to go from this one closest to the origin to the center one to the one furthest away and hit Enter or Spacebar. We can now hide these, or you can leave them on your call. And the next thing we're going to do is, now we have 3 curves in here, so what we want to do is kind of be able to select each one of these independently from one another. So I'm going to go to Set, and I'm going to grab the List Item component, which is right here. And then I'm going to zoom in on this component and hit the plus sign 2 times. And you can see that each one of my curves is now able to be dealt with independently from one another. And then I'm going to go to Curve, Division, and Divide Curve. And this process is going to set the number of primary ribs beams, or primary beams that we have. So I'm going to copy and paste that like I did here, and I'm going to pull that out of here. So as you can see, we're now dividing the I output and the 2 output out of that list item component, which are the 2 outer curves, if you will, the outer profiles. And then I'm going to go to parameters and grab one of these panels. Remember the yellow panels on your screen, they'll be yellow. Double click, I'm going to type in 22. And this is going to set the number of ribs that we'll have in the structure. So this is an important parameter. So I'm going to use my mouse, the scroll wheel, and I'm going to click down on the scroll wheel, and this little thing will pop up. I'm going to grab this green blob, which allows me to kind of put a group around something, or put this kind of white box around it. And on your screen, I think it'll be purple. And I'm going to right-click on that box, and I'm going to label this number of primary beams. Okay, because later on, this may be something we want to change. So it's one of our primary parameters. All right, so what I'm going to do now is draw a set of construction lines between these points. So I'm going to go to Curve and then Line up at the top here under Primitive, and I'm just going to connect the dots like so. Because what we're trying to do is divide this middle curve using these same distances that are between these points. And we can't just run that through another divide component, because this length is different than that length. And what we'll end up with is a slightly different spacing. So what we want to do is find the intersection and project upward. So let's find the intersection component that will do that for us. We can go to the Intersect tab, and I believe, let's see, maybe under Mathematical. Yeah, what we're looking for is the line plane intersection under Mathematical. So it looks like this, line plane. And let's look at what it needs here. It's going to need your input lines, and it's going to need some planes to intersect with. So this is kind of like taking sections through a curve, and you'll arrive at points. So our lines are here coming out of that component that we just drew. And we need some planes. So we need basically a plane in the right axis, or the right the right plane, at every one of these points. And we don't need them at all these points, just one set of them on this side, perhaps. So what we need is we need to find that point, which we know are here. We can go to vector, and we're going to put in an XZ plane. All right, so go to plane and then find the XZ plane and add an XZ plane to all those points. And then plug that in to there. And sorry, that was a simple mistake. Actually, what we need to do is place the XZ plane on the endpoint of our center line here, because this is where we're going to look for the intersections. Okay, sorry about that. So once you have this in place, simply go to curve, and up at the analysis, up at the top, you'll find endpoints. Okay, and bring your input into C out of the one output of your list item component over here, like that. And you're going to see there's 2 points now drawn along our center curve. We only need one of them, so we can just use the start point. And if we replace that input into our XZ plane, you'll see that we now have our intersections here. So basically, any line that intersects with that plane, which is a kind of a limitless, invisible plane that starts at this point, will be intersected, and you'll find a point there. So that's what these new points are. And then the next step is to project these newly found points up to our curve, so directly up in the z-axis. Okay, so we can go to vector. Under point, there's the project point command component. The points we're projecting are the result of our last operation here. The projection direction is going to be the positive z, so we can, while we're still in vector tab, go over to the vector panel over here, and you'll find unit z. So grab the unit z, plug that into the d input there, and then the geometry that we're projecting onto is once again the curve that's coming out of the one output there of our list item component. Okay, so we can shut a few things off here without confusing our screen. We don't have to, so we can turn those off. You can leave the rest of these on if you like. I'm going to turn these off because I think it's a little more clear, and I'm going to turn off the previews for my lines and get started like this. And this is you might recognize this is how we started when we were manually modeling as well. We may have done the opposite process. We may have divided this one first and then, found our sections and then mirrored across. I found it to be a little bit easier doing it in this way in Grasshopper for some reason, but you can try both. So we now have a set of 3 points. This set, and that set. And we want these sets to be correlated so that we can draw curves through them. And those curves are going to become our rails for the sweeping to make our beams. So go over to set, and under the tree panel all the way to the right, you'll find one called Endtwine. So grab the Endtwine component. And the Endtwine is going to allow us to kind of basically merge these 3 streams into a set like this. So you can see I'm putting them in order. I'm going to move that out of the way so you can see the inputs there. Okay. And if we look at what the data is coming out, now we've got all 3 of those sets nicely placed. And I'm just going to, just because good habits, I'm going to start turning off some older previews. These are all my sets. And now we can start drawing lines through, but let's see what happens when we do this. So let's go to curve, spline, and interpolate. And just go ahead and take the R output and plug it into the V input here. You can see what happened is the order is maintained through those lines. So when we select this, we're drawing the same line that we already have. What we really want to do is we want to reverse that relationship of points. We want it to go from the 0 index, 0 index, 0 index, and across this way. 1 to 2 to 3 to 4 to 5, and so on. Luckily, there's a nice simple way to do that. So you can go over to set, and then under the tree, you'll find flip matrix over to the right. So let's flip this matrix and then let's look at the output. So now what that did is it reversed the matrix. So in this case we had 3 lists of 23 items each. Now we have 23 lists, 3 items each. Replace that input into V as such, like this, and you'll see that now we've drawn our rail curves across the sets of points. Okay, so to complete our beams, what we need is a cross-section curve, the cross-section of the beam size, and it needs to be oriented to each one of those new curves that we just drew. And you remember doing that manually, rotating it into space, using Rotate 3D and all of that. We're going to do that in a much simpler way here, so go to Curve, Analysis, and Perpendicular Frame. So the perp frame is going to do exactly what it sounds like. It's going to add a perpendicular frame at any given point along a curve. The curves that we're putting in are the ones we just drew. The T parameter is something we can play with. So let's go to Parameter, Slider, and plug that in like this. Now you're going to see a little red plane, and again, if they're too big, you can go to Display, Preview Plane Size, and change the number there. Mine are fine as they are. And you can see that those things are turned in space relative to the curve that they're placed against. And now if I move the slider around, that starts to change ever so slightly. But you can see that from 0 to 1, I'm not actually getting a lot of distance out of that. And what we're expecting is that would go the entire length of the curve. So what this means is, because we drew those curves in Rhino, this parameter ends up being a dimensional parameter. We want this parameter to be a parametric parameter. So what we can do is, sorry, I realized that was redundant what I just said, but we need to describe this curve between 0 and 1 instead as a proportion instead of by dimension or by length. So all we need to do is right-click on the C input here and click Reparameterize, like this. And now if we try it, you'll notice now that as we scroll between 0 and 1 in this slider, that we're drawing a perpendicular frame at any given point. Now you can remove the slider and you can give it a whole range of values if you'd like between 0 and 1 using a domain or a series or something. But we actually only need to do, because of the way sweep works, we only actually need to draw one of these planes and one of these cross sections. We're not going to fuss with adding some more, let's say, depth to the beam or height to the beam in the middle. We're not going to do that for this. So we really only need this to stay at 0, so let's keep that there. And we're going to draw a rectangle, so go to Curve, Primitive, and Rectangle. And we can go ahead and plug our frames into the P input there. I'm going to turn the frames off so we can kind of visualize this a little bit better. And here's the size of the rectangle by default. We need to obviously change these X and Y inputs. So to do this, what we need to do is apply we need to apply a range to this instead of just a single dimension. So you can see as I hover over X size, it says -1 to 1, which is going to give me a centered square, and then -2 to 2 in the Y. So this is going to give me a centered square that is an overall value, in this case, especially because our units are in feet, it's going to give us a 2 foot by 4 foot cross section, which of course is much too large. So let's change this. Let's go to Math, and then the first component over here is called Construct Domain. And I'm going to copy and paste that to make 2 of them because we need 2. And then before I keep going, I'm going to right-click on the A input, and I'm going to go to Expression, and that's going to flop open this expression editor, and then I'm just going to type in -x and commit to those changes. And I'll explain that in just a second. So do that for both of them. -x, commit the changes. And then we're almost ready. The other thing is, because we're working in feet, the lines, I should say, from Rhino were drawn in feet, and we want to work in inches in Grasshopper because it's a bit more precise. What I'm going to do is just take all of my input values and just divide them by 12. So I'm going to go back to Math. I'm going to use the divider here, the division, and I'm going to need 2 of these as well. And then I'm going to grab a panel over in my Parameters tab and just plug in 12 into that. And I'm going to plug 12 into both B, that is, inputs here. And then I'm going to grab another panel, and I'm going to set my dimensions. So let's just say 9 in one and 6 in the other. and plug those in respectively into the A and the A input, like here. And then these can go, the result of that can go into both A and B in the domains as like this. And then I'm going to plug this one into my X and that one into my Y. So what I've now done is I've drawn a rectangle that is 18 inches by 12 inches. So these are times 2. And these are important parameters that we may want to change later. So I'm going to label those, and I'm going to call these size of primary beams. Okay. And these can be changed on the fly. And we never have to change this 12 because that's just a common denominator. So there's my beam sizes there, and they're all oriented perfectly along the line as I like. And now we just need to complete the sweep operation, which is to, it should be as simple as just going, sweeps can sometimes get a little tricky, but let's go to surface, freeform, sweep 1. The rails are these curves that we drew before, and of course our sections are there. Okay, looks like that worked very nicely, and there's our primary beams being drawn for us. And just to wrap up part 1, what I'd like to do is introduce you to just some custom previews, which will allow us to add a custom color to these members so that as we keep working, the red doesn't start to confuse our eyes a little bit. So what I'm going to do, I'm going to turn this off, the preview of sweep 1 off for now. I'm going to go to display tab up top, and in the preview area over here, the preview panel, you'll find the custom preview component. I'm going to plug that in. By default, the color is pink. We can go to parameters, back in the parameter tab, go to input, and you'll find a color swatch, and you can swap that out. And then if you click on this color right in the middle just once, this little pop-up window will appear, and you can change the alpha value, and you can of course change the color. I'm going to leave mine just kind of a boring white at about with an alpha value with, like, I don't know, something so I can sort of see through it like a ghosted preview in Rhino, something like that. Okay, this will help as we move forward. Okay, so that wraps up part 1. The next steps we'll add the secondary beams.